Hello, in this video we're going to have a look at intersecting loci. So rather than having one set of instructions that we're going to need to follow, we're going to have two or more that we need to meet. So let's have a look at example. We've got three students, we've got Ben, Josie and Kate, and they're going to run some sort of stall at a school event. They've decided that they're going to run a buried treasure competition, and they're going to have a table that's 80 centimetres by 50 centimetres, and somewhere in the table they're going to bury some treasure. We've got a scale up here, so 1 centimetre is 10 centimetres, so I've drawn this as 8 centimetres long and 5 centimetres high. So we've got three conditions that they're going to meet. They have decided that they want to try and keep everybody happy, and they're going to try and find an area that meets all three conditions. The question then goes on to say, by accurate construction, show the region where they should bury the treasure. Now I'm going to do this question twice. First time through, I'm just going to sketch on my diagram where I need to put my lines and work out where my areas are, so we can just concentrate on the techniques. And then I'm going to run through and do the question properly, and I'm going to use my accurate constructions and show you how to complete the question properly. First things first, we're going to sketch. So Ben, he wants the treasure to be closer to C than to D. So my point here, C, bottom right hand part of my table, D, my bottom left corner. So he wants it closer to C than D. When we've got these questions, what we want to think about are the boundaries. So we want to think about the points that are the same distance away from C and D. So what are they? Well, if I have a think about my line CD itself, the point that's the same distance away from D than C is going to be my midpoint, which is going to be somewhere here, and that's going to be, well, if length is 80 centimetres, then that's going to be 40, so it's going to be the same distance from D as it is from C. I also get, if I were to draw a vertical line, I'm going to get a whole series of points here that are the same distance from D as they are from C. So if I took a point here and I measured this distance, it would be exactly the same as this distance. So this needs to be a vertical line, needs to be perpendicular to my baseline. So what I've actually drawn, well, I've worked out that this is my midpoint of my line DC, and this is a perpendicular line, so the line that I want is a perpendicular bisector. So if I've got 2 points and I'm trying to find a set of points that are the same distance away, if I draw a line between those points and draw a perpendicular bisector, that's going to give me the same the set of points that are the same distance away from C as they are from D. So if I can draw my perpendicular bisector, I can keep Ben happy, I can work out which part of the table he wants. Josie, she wants it to be further away from BC, so right hand side of my table, than it is from BA, the top edge. So I've got a line here and a line here, and I'm looking for a set of points, and again I want to think about what the boundaries are. So I want the set of points that are going to be the same distance from BC as they are from BA. Well, that's going to be a line of points that are going to sit on this line here, and this line is going to be my angle bisector. So this is a rectangle, so I've got a right angle in the corner. If I cut that angle in half, that's going to be 45 degrees. So all of the points along that line are the same distance away from this line as they are from that line here. So if I've got two lines and I want a set of points that are the same distance away, I'm always going to end up with an angle bisector. So the reason why we've got so much practice over the last couple of lessons on perpendicular bisectors and angle bisectors, they're really useful for loci. So if I've got 2 points and I'm looking for a set of points same distance apart, I end up with a perpendicular bisector. If I've got 2 lines, then I'm looking for my angle bisector, chop that angle in half. All of the points along that line are the same distance away from BC as they are from BA. I've thought about Ben, thought about Josie. Let's have a think about what Kate wants. She wants the points to be less than 45 centimetres away from D. So again, I want to think about the points that are exactly 45 centimetres away from D. Well, just like we had in the first lesson, that series of points are going to sit on a circle, and I want the bit of circle that fits onto my table. So I'm going to put my compass on D. I've got this set at 4.5 centimetres, and if I draw an arc, all of those points on that arc are exactly 4.5 centimetres away from D. So that was actually an accurate construction rather than a sketch. So I've used three different techniques. I've got my perpendicular bisector, I've got my angle bisector, and I've got my distance away from a single point, which has given me a circular arc. And I can then think about which areas on the table I've got. So I've got a few different ones I could possibly be interested in, but I want to find the ones that meet all three conditions. And I've got two choices. First of all, I can try and work out which bit it is I'm interested in. Maybe it might be this bit down here, and then shade it in. But sometimes it's easier to shade the bit that you don't want. And I'm going to do that with the sketch, and when I do the accurate construction, I'll do the opposite, so you can see both techniques. So first of all, Ben says the treasure should be closer to C than it is to D. So we drew that perpendicular bisector. He wants it to be closer to C than D. So he's interested in anything in this bit over here. So what I'm going to do is I'm going to shade the bits that he doesn't want. So anything to the left of that perpendicular bisector. So that stuff there doesn't meet Ben's condition. Not interested in it. Josie says that it should be further away from BC than it is from BA. So she wants it to be further away from BC, so she wants it to be above that angle bisector there. So the bit that we don't want is the bit underneath the angle bisector, so this bit here. So I'm going to shade that because I'm not interested. So I'm left with this triangle at the moment. So we've done Ben, we've done Josie, let's have a think about Kate. So she wants it to be less than 45 centimetres, so she's looking for it to be inside that arc. She wants it to be closer to D than that 45 centimetres. So she's interested in nearer to D. I'm not interested in the stuff that's further away from that circular arc, and I can shade that in. I've already shaded this bit over here, and I'm left with this little region here. That little bit here meets all three conditions, and it's worth saying that I'm actually interested in the unshaded region. Let's do a double check. So Ben wanted the treasure to be closer to C than D. So yeah, or anything within that unshaded area is closer to C than D. It's on the right hand side of that line. Josie wants it to be further away from BC than it is from BA. So she wants it to be closer to BC. So this bit's above my angle bisector. So that's looking good. Kate says it should be less than 45 centimetres away from D, or anything inside that circular arc is going to be closer to D than 45 centimetres. So we've met Kate's condition and we've met all three. Okay, let's have a go at the accurate constructions. We know what we're aiming for. Let's see if we can do our constructions accurately. So first of all, Ben wants the treasure to be closer to C than D. So remember we were looking for that perpendicular bisector. So I've got my compass at the moment set at 4.5 centimetres. So I'm going to draw an arc above, and I'm going to draw one below my line. I'm going to move my compass without changing the setting. I'm going to put it on C, draw an arc above and below. If I take my ruler and I want to line up with the two crosses, so I've got that lined up. I don't want to draw my line from the bottom, I only want to draw it in the table. So I've got my perpendicular bisector accurately drawn. We can also have a sneaky check. 4 centimetres, not looking too bad. Happy enough with that. And so we've done Ben. Josie says it should be further away from BC than BA, so remember we're looking for that angle bisector. So I'm going to take my compass, I'm going to put it on B, and I'm going to draw 2 arcs on AB and BC. Then I'm going to move my compass, put it on that arc, and it's going to be there somewhere. And then I'm going to move it to the other point. I'm going to draw my second arc. Where that crosses, I want to connect that up to my point B. And so up to the point, I want to connect it up to the edge of the table. So that's my angle bisector. That's going to be 45 degrees. Had 19, I've cut it in half, so it must be a 45-degree angle. So I've got my perpendicular bisector, I've got my angle bisector. Let's have a look at Kate's instruction. She wanted it to be less than 45 centimetres away from D. So my compass goes on D, and I'm going to draw an arc. And we've met Kate's instruction. So this time, rather than shading the bits that I don't want, I'm going to shade the bit that I do want. I'm pretty happy that I'm looking for this piece here in the middle. Let's double check our instructions. Ben wanted it to be closer to C than D, so we're to the right of that perpendicular bisector. Josie said it should be further away from BC than it is from BA, so it's above that angle bisector. It's closer to BA than it is to BC. Kate says it should be less than 45 centimetres away from D. I'm inside my circular arc, and I've got this case I've got the shaded area. So relatively similar to my sketch. My sketch wasn't actually too bad, but this is using the accurate construction techniques. I've got my perpendicular bisector, I've got my angle bisector, and I've got my circular arc. So I've got 2 points, and I want a set of points at the same distance. I'm going to end up with a perpendicular bisector. 2 lines, and I'm looking for a set of points at the same distance away, angle bisector, and set of points same distance away from a single point. I'm going to get a circular arc. Okay, your turn to get some practice. Follow the instructions in the email and have fun.